Welcome to Part 6 topic, Supporting Compliance Requirements in Any Cloud Journey. Compliance does not begin with tools or configurations. It begins with understanding the rules that apply to your business. When an organization moves workloads to the cloud, it does not escape laws, regulations, or industry standards. In fact, the responsibility to follow them becomes even more important. Determining regulatory requirements for the cloud is the process of identifying which legal, regional, and industry-specific rules apply to your data, your workloads, and your operations, and then mapping those rules to how you design and run your cloud environment. The first thing to understand is that regulatory requirements are not universal. They depend heavily on who you are, where you operate, and what kind of data you handle. A healthcare company in the United States must follow healthcare regulations such as HIPAA. A business operating in the European Union must comply with data protection laws such as GDPR. Financial institutions, government agencies, and global enterprises each face their own sets of rules. The cloud does not change these obligations. It simply becomes the place where they must be enforced. To determine your regulatory requirements, you must start by understanding your data. Not all data is equal. Some data is public and carries little risk. Other data, such as personally identifiable information or protected health information, is highly sensitive and tightly regulated. Classifying your data based on sensitivity and legal obligations is a critical early step. Once data is classified, you can clearly see which datasets are subject to compliance requirements and which are not. The next step is understanding where that data lives and how it moves. Regulations often include data residency rules that require data to remain within specific geographic regions. When data crosses borders, different laws may apply. In the cloud, data can be stored, processed, and backed up across multiple regions if you are not careful. Determining regulatory requirements means identifying where your data is allowed to reside and ensuring your cloud architecture respects those boundaries. It is also important to understand how your cloud service provider fits into the compliance picture. Cloud providers like Google Cloud offer many services that are certified or assessed against common compliance standards. These certifications help demonstrate that the platform meets certain security and compliance expectations. However, using a compliant cloud service does not automatically make your organization compliant. You remain responsible for how you configure services, control access, and protect data. This is where the shared responsibility model becomes essential. In the cloud, security and compliance responsibilities are divided between the provider and the customer. The provider is responsible for securing the underlying infrastructure, such as data centers, physical hardware, and core networking. You, as the customer, are responsible for how you use the platform. That includes managing identities, controlling access, configuring security settings, and ensuring your workloads meet regulatory requirements. Determining regulatory requirements means understanding exactly where your responsibility begins and ends. Once you know which regulations apply, you must identify which cloud services are allowed to handle regulated data. Not every cloud service is suitable for every compliance requirement. Some services are explicitly approved for certain regulations, while others are not. Reviewing the compliance status of cloud services helps ensure that regulated data is only processed by services that meet the necessary standards. Finally, determining regulatory requirements is not a one-time activity. Regulations evolve, businesses expand into new regions, and data usage changes over time. Compliance must be continuously reviewed and reassessed. As new workloads are deployed and new data is collected, you must repeatedly ask the same questions. What data is this? Where is it stored? Who can access it? Which laws apply in the cloud? Compliance is not achieved by accident. It is achieved through awareness, deliberate design, and continuous validation. By clearly determining regulatory requirements early and revisiting them often, organizations can build cloud environments that are not only powerful and scalable, but also lawful, trustworthy, and secure. Topic determining concerns relative to compute, data, network, and storage. When we talk about securing a cloud environment, it is easy to think in terms of individual services or tools. But effective security begins earlier, with understanding where your real risks live. In Google Cloud, those risks generally fall into 4 major domains: compute, data, network, and storage. Each of these areas has its own threat model, and each requires a different way of thinking. Let us begin with compute. Compute resources are where your workloads actually run. Virtual machines, containers, managed services, and serverless platforms all execute code on your behalf. From a security perspective, the primary concern with compute is control over execution. Who is allowed to create, modify, or access these workloads? What identities do they run as? And what permissions do those identities carry? A compromised compute resource is dangerous because it can act as a launch point for further attacks. If an attacker gains access to a virtual machine or container, they may attempt to escalate privileges, move laterally to other services, or access sensitive data. This is why securing compute is not just about hardening the operating system. It is about enforcing least privilege for service accounts, limiting administrative access, keeping images trusted and up to date, and ensuring that workloads are isolated from one another wherever possible. Next, we turn to data. Data is often the most valuable asset in any system, and it usually represents the highest impact if compromised. In cloud environments, data exists in many forms: databases, logs, backups, analytics datasets, and application-generated content. The core concern here is not just unauthorized access, but also accidental exposure and misuse. Protecting data means understanding who can read it, who can modify it, and where it flows. Encryption plays a critical role, both at rest and in transit, but encryption alone is not enough. You must also consider identity and access controls, auditability, and data classification. Sensitive data should be clearly identified, access should be tightly scoped, and all access should be observable through logs. When data moves between services or across trust boundaries, those paths must be intentional and secured. Now consider the network layer. The network defines how resources communicate with each other and with the outside world. In Google Cloud, networking is global, software-defined, and extremely powerful. That power also introduces risk if not carefully managed. The primary concern with network security is exposure. Every open port, every public IP address, and every routing rule represents a potential entry point. A misconfigured firewall rule or overly permissive network path can unintentionally expose internal services to the internet. Network security is therefore about minimizing what is reachable, controlling traffic flow, and enforcing clear boundaries between systems. This includes segmenting networks, using private connectivity wherever possible, and tightly controlling ingress and egress traffic. It also means monitoring network activity so that unexpected communication patterns can be detected early. Finally, we come to storage. Storage systems hold persistent data, often for long periods of time. Object storage, block storage, and file systems all fall under this category. The concern here is long-term exposure. Storage resources are frequently shared, reused, and accessed by multiple services, which increases the risk of misconfiguration. A single storage bucket configured for public access can lead to massive data leaks if left unchecked. For this reason, storage security focuses heavily on access policies, default configurations, and continuous review. You must be clear about who owns each storage resource, who can access it, and whether that access is still necessary. Encryption, access logging, and lifecycle management all help reduce the risk that stored data becomes a silent liability. When you step back and look at compute, data, network, and storage together, a pattern emerges. Security is not about protecting individual services in isolation. It is about understanding how these components interact, how trust is established between them, and where failures would cause the greatest harm. By systematically identifying concerns in each of these domains, you create a mental map of your cloud environment's risk landscape. That map becomes the foundation for every security decision you make going forward. Topic: evaluating the shared responsibility model in cloud computing. Security is not owned by a single party. It is shared. And understanding exactly how that responsibility is divided is one of the most important steps in building secure and compliant systems on Google Cloud. This idea is captured by what is known as the shared responsibility model. At its core, This model explains which security tasks are handled by Google Cloud and which ones remain firmly in the hands of the customer. Many security failures in the cloud don't happen because the cloud provider failed. They happen because this division of responsibility was misunderstood. Google Cloud is responsible for securing the foundation. This includes the physical data centers, the buildings, the servers, the networking equipment, and the underlying infrastructure that runs everything. Google designs its own hardware, controls physical access to facilities, encrypts data at rest by default, encrypts data in transit, and follows secure software development practices across its platforms. All of this happens behind the scenes, and customers never have to manage it directly. But once you move above that foundation, responsibility begins to shift. Customers are responsible for how they use the cloud. This includes protecting their data, configuring access controls, managing identities, defining network rules, and ensuring that workloads are deployed securely. In other words, Google secures the cloud, but customers are responsible for security in the cloud. This responsibility also changes depending on the type of service being used. With infrastructure services, such as virtual machines, customers manage more of the operating system and configuration. With platform services, Google takes on more responsibility, but customers still control how applications are built and accessed. With software services, Google manages even more, but customers are still accountable for user access, data handling, and compliance decisions. Evaluating the shared responsibility model means looking at how this division aligns with your real-world obligations. The first thing to consider is regulatory compliance. Every organization operates under laws and regulations, whether it is healthcare, finance, government, or data privacy. Google Cloud provides services that meet many regulatory standards, but using those services correctly is still your responsibility. For example, if you are handling regulated healthcare data, you must ensure that the services you choose are eligible for that regulation and that your architecture follows the required safeguards. Next, you must compare the model with your organization's internal security standards and risk management plan. Every organization has its own tolerance for risk and its own security policies. The shared responsibility model should fit naturally into those policies, not conflict with them. If your organization requires strict access controls, detailed logging, or specific encryption practices, those controls must be implemented by you, even if the underlying platform is already secure. Another important factor is the security expectations of customers and partners. Many organizations are part of a larger ecosystem. Your customers may expect certain protections for their data, and your vendors may impose their own security requirements. Evaluating the shared responsibility model helps you understand whether Google Cloud provides the capabilities you need, and whether you are configuring them properly to meet those expectations. Finally, workload type matters. Different applications have different risk profiles. A public-facing web application, an internal analytics platform, and a system processing sensitive personal data all require different security approaches. The shared responsibility model helps you understand where Google's protection ends and where your design decisions begin for each workload. In the end, the shared responsibility model is not a limitation. It is a framework. It clarifies accountability and prevents dangerous assumptions. Google Cloud provides a secure, resilient foundation, but true security and compliance depend on how well customers understand their role and act on it. When evaluated carefully, this model becomes a powerful tool for building systems that are not only functional, but trustworthy, resilient, and compliant by design. Topic: configuring security controls for compliance. When organizations move to the cloud, compliance stops being a one-time checklist and becomes an ongoing design responsibility. Configuring security controls for compliance is about translating laws, regulations, and industry standards into concrete technical controls inside your cloud environment. In Google Cloud, this means understanding what you are responsible for, what Google is responsible for, and how to configure services so that data, identities, networks, and workloads all behave in a compliant way. The process begins with a clear understanding of your compliance obligations. These obligations depend on where your organization operates, where your customers are located, and the industry you belong to. Healthcare organizations may need to comply with HIPAA, financial institutions with financial regulations, and companies operating in Europe with GDPR. These rules define how data must be stored, accessed, protected, and audited. Without understanding these requirements first, it is impossible to configure the right controls. Once the regulatory landscape is clear, the next step is to identify which cloud services and which data fall under those regulations. Not all workloads are equal. Some applications process regulated data, while others do not. Some datasets may contain personal or sensitive information, while others are public or internal only. This is why data classification is so important. By classifying data based on sensitivity and regulatory impact, you can focus your strongest controls where they are truly required. A key concept in configuring security controls for compliance is the shared responsibility model. In Google Cloud, Google is responsible for securing the underlying infrastructure. This includes physical data centers, hardware, networking, and the core cloud platform. Google also encrypts data at rest and in transit by default. The customer, however, is responsible for how cloud services are configured and used. This includes identity and access management, network configuration, data protection policies, logging, and monitoring. Compliance failures almost always happen on the customer side, through misconfiguration or overpermissive access. From a compute perspective, compliance means ensuring that workloads run in approved environments and are accessed only by authorized identities. This is achieved by carefully configuring IAM roles according to the principle of least privilege. Users, service accounts, and applications should have only the permissions they need, nothing more. Overprivileged identities increase the risk of accidental exposure and regulatory violations. For sensitive workloads, additional controls such as workload isolation, confidential computing, and shielded virtual machines can further reduce risk. Data controls are at the heart of most compliance requirements. Data must be protected at rest, in transit, and during processing. Encryption is essential, and in many regulated environments, customer-managed encryption keys are preferred to give organizations direct control over key access and rotation. Data loss prevention tools help discover and classify sensitive data, ensuring that regulated information is not stored in the wrong place or exposed unintentionally. Lifecycle policies and retention controls ensure that data is kept only for as long as regulations require, and no longer. Network configuration also plays a critical role in compliance. Virtual private cloud networks define where workloads can communicate and which services they can reach. Firewall rules, private access configurations, and network segmentation reduce the risk of unauthorized access. For highly regulated environments, service perimeters can be used to prevent data exfiltration and restrict access to cloud services from approved networks and identities only. Proper network isolation ensures that even if one component is compromised, regulated data remains protected. Another major pillar of compliance is regionalization. Many regulations require that data remain within specific geographic boundaries. Google Cloud allows organizations to choose where resources are created and where data is stored. Organization policies can be used to restrict resource creation to approved regions. Assured Workloads takes this further by providing a guided way to deploy compliant environments that enforce data residency, restrict Google personnel access, and apply compliance-specific controls automatically. This reduces human error and ensures consistent enforcement of regulatory requirements. Logging and monitoring are essential for proving compliance, not just achieving it. Audit logs provide a record of who accessed what, when, and from where. These logs support non-repudiation and are often required during audits and investigations. Monitoring helps detect misconfigurations, suspicious behavior, and compliance drift over time. Security posture management tools can surface non-compliant resources and help teams remediate issues before they become violations. Transparency and trust are also important aspects of compliance. Access transparency logs show when Google personnel access customer data, providing visibility into actions taken by the cloud provider. Access approval allows customers to explicitly approve or deny certain access requests. These features strengthen separation of duties and help organizations meet strict regulatory expectations around oversight and accountability. Configuring security controls for compliance is not a single configuration task. It is a continuous process that evolves as regulations change, workloads grow, and new services are introduced. By understanding regulatory requirements, applying least privilege access, protecting data and networks, enforcing regionalization, and maintaining strong logging and monitoring, organizations can build cloud environments that are not only secure, but also demonstrably compliant. In the cloud, compliance is not about slowing innovation. It is about designing guardrails that allow innovation to happen safely, consistently, and with confidence. Restricting compute and data for regulatory compliance. Regulatory compliance is one of the most demanding responsibilities in cloud security. When organizations move sensitive workloads to the cloud, they are no longer just protecting systems from attackers. They are also proving, continuously, that they are following the laws and regulations of the countries and industries in which they operate. This is where restricting compute and data becomes essential. Different regulations place strict requirements on where data can live, who can access it, and under what circumstances that access is allowed. Healthcare regulations may require patient data to stay within national borders. Financial regulations may demand strong controls over who can operate critical systems. Government workloads may require assurance that only approved personnel can access sensitive environments. In the cloud, these requirements are enforced not by policy documents alone, but by technical controls. Google Cloud provides several built-in mechanisms that help enforce these rules in a practical and auditable way. At the foundation of these controls is the idea that access to compute and data must be intentional, minimal, and transparent. Restricting compute access starts with controlling who can create, modify, and operate resources such as virtual machines, containers, and managed services. Identity and access management defines exactly which users, groups, or service accounts can perform specific actions. Instead of giving broad administrative access, permissions are carefully scoped to job roles and responsibilities. This ensures that even if an account is compromised, the attacker cannot freely control all compute resources. Network-level restrictions add another layer of protection. By isolating workloads inside private networks and enforcing service perimeters, organizations can prevent data from being accessed or exfiltrated outside approved boundaries. Even if credentials are leaked, requests coming from outside trusted networks can be blocked. This is especially important for regulated environments where data must not cross organizational or geographic borders. Restricting data access requires a deeper understanding of what data exists and how sensitive it is. Data must first be classified so that regulated information such as personal data, financial records, or health information is clearly identified. Once classified, protections can be applied consistently across storage systems, databases, and analytics services. Encryption plays a central role here. Data is encrypted while stored and while moving between services, ensuring that even if access controls fail, the data itself remains unreadable. In highly regulated scenarios, organizations can manage their own encryption keys, giving them direct control over when data can be decrypted and by whom. Data loss prevention tools further strengthen these controls by automatically discovering sensitive information and applying masking or redaction when needed. This reduces the risk of accidental exposure, especially in large environments where manual data tracking is impractical. Monitoring and auditing are what turn these controls into proof of compliance. Every meaningful action taken on compute resources or data is recorded. Audit logs show who accessed what, when the access happened, and from where it originated. This creates a trail of evidence that can be reviewed internally or presented to auditors to demonstrate compliance. Security monitoring tools analyze this activity continuously, looking for misconfigurations or suspicious behavior. If a resource is created outside an approved region, or if permissions become overly broad, alerts can be triggered before the issue turns into a violation. Beyond technical enforcement, trust and transparency are also critical. In regulated environments, organizations must know when cloud provider personnel access their data, even for support or maintenance. Access transparency provides visibility into these actions by logging every instance where provider staff interact with customer data. This removes uncertainty and builds confidence that access is controlled and justified. Access approval goes one step further by allowing organizations to approve or deny certain access requests in advance. Instead of learning after the fact that access occurred, customers remain in control, deciding whether access is allowed based on the situation. This level of oversight is often required for government and highly sensitive workloads. Together, these controls form a comprehensive approach to regulatory compliance. Compute resources are restricted to authorized operators. Data is confined to approved locations and protected by encryption. Every action is logged, monitored, and reviewable, and access by external parties is made transparent and, when required, explicitly approved. By combining these mechanisms, organizations can confidently run regulated workloads in the cloud, knowing that compliance is not just a promise, but something that is enforced, measurable, and continuously maintained. Topic: Determining the Google Cloud environment in scope. For compliance, before any organization can confidently say it is compliant in the cloud, it must first answer a fundamental question: which parts of the Google Cloud environment are actually in scope for compliance? This step is critical because compliance does not automatically apply to everything you run in the cloud. It applies only to the services, data, networks, and identities that are governed by specific laws and regulations. The process begins with understanding the regulatory requirements that apply to your organization. These requirements depend on your industry, your geographic location, and where your customers are located. Regulations such as GDPR, HIPAA, PCI DSS, or regional data protection laws clearly define what kind of data must be protected, how it should be handled, and where it is allowed to reside. Once these rules are understood, they become the lens through which you examine your Google Cloud environment. With regulatory obligations clearly identified, the next step is to determine which Google Cloud services are involved in handling regulated data or workloads. Not every service you use may fall under compliance requirements. For example, a project hosting public marketing content may be out of scope, while another project processing personal or financial data is fully in scope. Google Cloud provides compliance documentation and service eligibility lists that help identify which services support specific regulations. This allows you to confidently narrow the scope to only the relevant services and avoid unnecessary compliance overhead. After identifying the services, attention shifts to data itself. Data classification is a crucial activity at this stage. Data must be categorized based on its sensitivity and regulatory impact, such as personal data, financial records, or protected health information. Once classified, an inventory of where this data lives across Google Cloud must be created. This includes storage services, databases, analytics platforms, and backups. By knowing exactly where regulated data resides, you can clearly define which resources are in scope and ensure they are protected accordingly. Network configuration is another important factor in determining compliance scope. The way networks are designed can directly affect compliance. Virtual private clouds, subnets, firewall rules, private access configurations, and service perimeters all influence how data flows within and outside your environment. If regulated data can move freely across networks or leave controlled boundaries, compliance may be at risk. Evaluating network design helps confirm that only approved paths and regions are used for sensitive workloads. Access control and identity management also play a major role in defining the compliance boundary. You must review who has access to regulated data and systems, and how that access is granted. Identity and access management policies should follow the principle of least privilege, ensuring users and service accounts can only perform actions necessary for their roles. Accounts with broad or unnecessary permissions may unintentionally expand the compliance scope and increase risk. Finally, Audit logging and monitoring complete the picture. Any environment in scope for compliance must have visibility into who accessed what, when, and from where. Audit logs provide this evidence and are often required by regulators. Monitoring ensures ongoing compliance by detecting unusual or unauthorized activity. Services such as cloud audit logs, monitoring tools, and access transparency features help maintain accountability and trust over time. By systematically reviewing regulatory requirements, identifying relevant services, classifying data, evaluating network design, tightening access controls, and enabling robust logging, organizations can clearly define the exact portion of their Google Cloud environment that is in scope for compliance. This clarity is essential. It allows security teams to focus their efforts where it truly matters, reduce unnecessary complexity, and build a cloud environment that is both compliant and secure by design. Summary OFT Part 6 Chapter 6 focuses on how organizations can meet regulatory and compliance requirements while operating on Google Cloud. It explains that compliance in the cloud starts with understanding the legal and regulatory landscape that applies to an organization, such as data protection laws and industry-specific regulations. These requirements vary based on geography, industry, and the type of data being handled, and they directly influence how cloud resources must be designed and managed. The chapter emphasizes evaluating concerns across compute, data, network, and storage. Each of these areas introduces unique risks related to security, data residency, access control, and cost management. Addressing these concerns requires careful selection of services, secure configurations, encryption, and continuous monitoring. A key concept explained is the shared responsibility model. Google Cloud is responsible for securing the underlying infrastructure, while customers are responsible for securing their workloads, identities, data, and configurations. Understanding this division of responsibility is essential to designing compliant cloud architectures. The chapter then explains how to configure security controls to support compliance, with a strong focus on regionalization of data and services. Tools like organization policies, assured workloads, and security blueprints help enforce where data can reside and how resources can be deployed, ensuring alignment with regulatory requirements. It also covers restricting compute and data access to meet compliance needs. This includes using identity and access management, network isolation, data classification, encryption, and monitoring. Transparency and trust are reinforced through services that provide visibility into access and actions within the cloud environment. Finally, the chapter explains how to determine which parts of the Google Cloud environment are in scope for compliance. This involves identifying applicable regulations, relevant services, sensitive data, network configurations, access controls, and audit logging. By clearly defining this scope, organizations can focus their compliance efforts effectively and maintain a secure, compliant cloud environment.